Okay, we're looking at another one of your central limit theorem questions. So notice that we're given a population that has a mean of mu equal to 97.6 and sigma equal to 59.8. And you intend to draw a random sample size of n equals 60. Now recall what the central limit theorem says. The central limit says that if you're given a population with any distribution other than, it doesn't say normal on it. If they just said, here's your distribution, if your sample size is greater than 30, then we can assume that this is a normal population, and we can apply the normal the probabilities of the area under the normal curve. The only thing that changes is, okay, your mean, since you're drawing a sample, you're getting a sample mean. It's still going to be mu sub x bar, which is the same thing as mu. The only thing that changes is your standard deviation, and you have to divide that by the square root of n. And your z-score changes. Just a little, again, this is the old z-score for just a single value x, and this is for the mean. If they do, I did forget to point this out, if they do tell you it's a normal distribution, and you're drawing a random sample, then you don't have to have the sample size greater than 30 if it states that it's normal. So notice that it doesn't state that it's normal in this question, but since that sample size n is greater than 30, we can apply the central limit theorem. So, to work this problem, we're going to find the probability that x bar is less than 78.3. So what we have to do is we have to find the z-score for this. So, and then the z-score formula is going to be z is equal to x bar minus mu over sigma over the square root of n. Okay, because we're dealing with the mean. So we're going to look at this value here for x bar. Okay, it's going to be equal to 78.3. Subtract off mu, which is 97.6. Divide that by 59.8 and divide that by the square root of 60. Now notice that when you have a, this is a fraction. Here's your numerator and here's your denominator. But your denominator has a fraction in it as well. This is called a complex fraction. And I normally tend to do, when a complex fraction, I'll do the standard straight line to separate the numerator and denominator, and then if I've got a fraction in my denominator, I'll do the slash. Just something that I do personally. So let's go ahead and calculate this. So 78.3 subtract off 97.6 equals. I'm going to leave that in my calculator. Now recall back from probably elementary school, or maybe even algebra, that when you are simplifying a complex fraction, you take your numerator divided by your denominator, and if your denominator is a fraction, you actually are going to invert this and multiply them. So let me just write that down. This, if I was to evaluate this, I'm going to do it on my calculator though. This would be like negative 19.3. Okay, it's going to be divided by 59.8. This actually comes to the top, and you're going to say times the square root of 60. I'm just looking back on how to simplify a complex fraction. Google that if you need to. So when I get here, I've already did the top, so I'm going to simply say divided by 59.8 and enter, and I'm going to say times second square root of 60. So it's going to be negative 2.4, and I'm going to go probably 4 places with this. 2.49. Well, actually, that'd be 2.5000. Okay, all right. If I go 4 places with it, 500. Because you go to your fifth one if it's 5 or more. I mean your fourth one, 1, 2, 3, 4, and that increases that one, and so on and so forth. So really, this problem up here, we rewrite the probability statement. It's going to be approximately the same thing. The probability that z, and use your same inequality symbol, is less than, and then you put in this z value, and we'll just do negative 2.5 if it had more significant digits out here, I would have entered that in there. So, I'm going to go down here and draw this curve. Okay, locate negative 2.5. We know that's the left of 0. Okay, and since it's less than, that means that I draw my line up and I shade to the left. Okay, so I'm wanting to find this area. Okay, and recall on your TI, that's going to be normal, CDF. Since it's to the left all the way here, remember that we use the negative 999, 999, comma, negative 2.5. And that's going to give me the area. Second bars, normal, CDF, enter, 999, 999, comma, negative 2.5, equal 0.0062. Okay, now let's go to stat desk. Analysis, probability, normal. I'm going to go Z, since Z, stat desk is going to give me to the left, so I've got it the way I want it to look like anyway, negative 2.5. Evaluate. Notice that your cumulative probability to the left is going to be the 0.00621. Notice that it gives me the right two down here. So, and if you was to add these two together, that would give you 1. So really, I wouldn't necessarily have to do a subtraction from here, I don't think. But we'll let's go ahead. Looks like to 3 decimal places be 0.006. Let's put that in there. Let me know if you have any questions. Thanks.